Hi, you're on mute.
Hi. Sorry. Yep. I'll continue. Okay. So I'm just going to the revision of what we studied yesterday, and then we'll continue from where we left. So, what is abstraction? Abstraction is the process of hiding detailed information and only presenting the essential information to the user. For example, car can be viewed as a car rather than its individual components. And abstraction can be achieved using the abstract class or abstract interfaces. Any user can use a method without knowing about its implementation details. And example, implementation body of the method black box is hidden from the user in this example. When we use system.out.println on the method to display a string, we do not bother about how it is implemented. For example, sending SMS, when you type text and send message, you don't know the internal processing about the message delivery. All you care is that the message should be delivered. Abstraction lets you focus on what object does instead of how it does it. Okay, let's talk about abstract classes. So, any class that is defined with an abstract keyword is called an abstract class, and any function that is defined with the abstract keyword is called an abstract function. Now, abstract classes cannot be it cannot be used to create an object. Okay, so as you can see, you can only extend them, you can't instantiate them. So if a class extends an abstract class, then it must implement all of its method. So you can see that this abstract class is a method called run, and here is where it's implemented. So it does something now. Okay, it can also have constructor and static methods. It can have final methods which will force the subclass not to change the body of the method. Okay, now we talk about encapsulation, which is the process of binding the data members and methods together. It is done securely by making the data field accessible only to the class members by declaring the data fields as private. Everyone outside of the class knows how to access it and use the methods without thinking about its implementation. As discussed earlier, we can use setters or getters method to access the private variables from outside of the class into another class, which extends it, inherits it. Okay, inheritance provides reusability by inheriting the property in the new class from a derived class. It is a process by which one object acquires the property of another object, which means all the methods and properties of a parent class will be available into the child class. It allows the creation of a new class similar to the previously one defined, and the new class can have its own data members and method. This makes it useful in case if you want to make any changes, all you have to do is just make a change in the parent and it all be available in the child classes as well. Okay, parent classes are called superclasses and child classes are also called subclasses. What are the advantages of inheritance? It can reduce the development time because it offers reusability. If there are child classes which inherits the parent class methods and properties, we don't have to redefine them in the child class. Less execution time, less memory, redundancy of the code can be minimized. Flexibility. So, as I explained earlier, you can change the code in the parent and it will be available in the child. Overriding with the help of inheritance, you can override the methods of the base class, which means parent class, into child class. You can achieve data hiding. So, the base class in inheritance decides which data to be kept private, such that the derived class will not be able to alter it. So, if there's a parent class and if you want some of its data not to be changed by the child classes, you can set it as private. Different types of inheritance. You have single, multi-level, and hierarchical. In single-level inheritance, one class is inherited by another class. Okay. In multi-level inheritance, one class is inherited by another class, and that inherited class is inherited by another one. So in this case, um, B inherits A and C inherits B. In hierarchical, there are multiple classes which inherit the same class. In this case, B and C inherit A. Okay, this is an example of the program for the single level inheritance. This is an example of multi-level, and this is an example of hierarchical. Okay, member access and inheritance. Often an instance variable of a class will be declared private to prevent its unauthorized use or tampering. Inheriting a class does not override the private access restriction. Thus, even though the subclass includes all of its members of the superclass, it cannot access those members of the superclass that have been declared private. We already know about this. So, this basically topics talks about when the inheritance occurs, what are the rules for that. So, we discussed that anything that's declared private in a parent class cannot be accessed in a child class unless you use getters and setters. Then we have polymorphism and its advantages. So poly means many, and morphism means forms. So polymorphism means that something that can take many forms. So polymorphism is an ability of an object to take many forms, because Java is all about objects, right? Everything is an object in Java. So that is why we're talking about object to take many forms. It allows one interface to be used for a general class of actions, and it's implemented with two methods: overloading and overriding. Overloading means allowing the same method to perform similar or closely related functions through a common name. Overriding means uh, you can define the same method of a parent class in the child class but make it do something else. It tends to reduce the pairing of multiple functionalities and allows programmers to reuse, evaluate, and execute the program's modules forms written once. There are different types of polymorphism. You have static and you have dynamic polymorphism. Static is linking of the function with an object during compile time. It's achieved through overloading. And dynamic polymorphism, compiler does not determine the method to be executed. JVM performs the process at the runtime, and it's achieved through overriding. So this is an example of overloading. You can see this same function sum is being called different times. They're passing different parameters. So making the function do more and every time with a different parameter. That's overloading. Overriding, basically single method draw in this example can be used to draw different shapes like triangle, circle, rectangle. So this is your parent class and these are child classes. The same method draw is redefined in each of these child classes, but it's doing something else. Like here it's calculating the area of a triangle, here it's circle, and the third one is rectangle. The use of super keyword in Java. So we discussed yesterday that sometimes if you have the same name of a particular function in the child class as it is in the parent class as well. For example, in parent you have animal sound, and child also you have the same function name. To avoid confusion, we can use the word super. If you call a function by saying super dot and whatever the function name is, then the system is going to understand that you're calling a parent's function and not child's function. So that's why the super keyword is used. Modifiers in Java, there are four types of access modifiers: private, default, protected, and public. Private means that It's only available inside the class. It cannot be accessed from outside the class until you use getters and setters. Default means that if you don't define access modifier for a function or a variable, then it is treated as default, and it's only available within that package. It cannot be accessed from outside the package. If you do not specify access levels, it will be default. Protected means the access level of the protected modifier is within the package and outside the package through the child class. If you do not make any child class, it cannot be accessed from outside the package. Public is the access is publicly available and can be modified everywhere. It can be accessed from within the class, outside the class, within the package, and outside the package. Okay, use of constructor with the help of a program. So we discussed yesterday that um, if we don't define a constructor method, the system automatically defines the constructor method, and constructor method is automatically called when the class is instantiated. And if there's anything that we require in the class to happen at the time of instantiation, we can do all of that inside of the constructor method. The name of the constructor method needs to be the same as the name of the class. And the difference between the two functions, which is this main and the constructor function. So let's not get confused with this main and this main. The class name could be different. Let's say the class name was hello world. This will also be hello world. Difference between the constructor and this main function is that main function is treated as the entry point, that any Java program has to have a main function in order for it to run. And it again, it also gets automatically called. And the constructor function is basically um, automatically defined by the system in case if you don't define it, and gets automatically called during the instantiation. So constructor allow the creation of instances of a given class. That's the purpose of it. Order of execution. Every class has its own constructor, therefore execution of the constructor starts after the object initialization. So in single inheritance, constructor for base class is executed first, which means the parent class is executed first. In multi-level inheritance, all upper class constructor are executed first. Calling the same constructor using the keyword, this keyword. Here inheritance is not implemented, but there can be multiple constructor of a single class, and those constructor can be accessed using this keyword. So we discussed yesterday that a class can have multiple constructors and they can be accessed using this keyword. Calling superclass constructor using super keyword. This we already discussed yesterday. Sorry, yeah, that you can access the constructor method of a parent class using super keyword. Okay, let's talk about use of static method in Java. And I want somebody else to read it now. Who all are there? Kritika, you want to read?
Yes, okay.
Okay, let's start.
The static keyword is used to construct methods that will exist regardless of whether or not any instances of the class are generated.
Hmm.
Um, any method that uses a static keyword is referred to as a static method. Static methods have access to class variables or static variables without using the class's object or
Okay.
instance.
Okay, so in simple words, whether it's a static variable or static class, that you can access it without instantiating the class. Okay, so that's what it talks about here. That static keyword is used to construct methods that will exist regardless of whether or not any instances of the class are generated. So if you define a class and you don't create an object out of that, those methods will also be available, irrespective of whether you create an object or not. Okay, so let's take an example of this. There's a class called student. You have a static variable called college, the type string. Okay, and then you have a static method also. So this is static variable because it has static keyword before that, and then you have a static method because there's static keyword before that method. Okay, so this method basically is changing the value of college to this one. Earlier it was this one and changing to this one. Okay, and then let's see what else is happening. This is the constructor, and this is the display. Now let's see what's happening here. Okay, so public static void. So this is your main function, and inside of this we are calling student dot change. Now notice that we have not really created an object at this line number. Objects is getting created at the bottom, but we can still call this function. So that's what it's talking about, that if you define any particular method or a particular variable as static, irrespective of whether you have created an object out of that, it's going to be available. So that's why if you call student.change function, then it's going to be available. You will not get any error. And at this point we're just creating these objects, passing different values, and then calling the display method. Now let's talk about the advantages and disadvantages of garbage collection. Okay, Kritika?
Yes, advantages and disadvantages of garbage collection. In the garbage collection process, Java free the dynamically allocated memory which is no longer referenced. Advantages: it can make programmers more productive. Second advantage of garbage collection is that it ensures a program integrity. Disadvantages: it adds overhead to the system, which adversely affects performance. The programmers in a garbage collected environment have less control over the scheduling of CPU time, as it is devoted to freeing objects that are no longer needed.
Okay, so I think in most of the programming language, whether it's PHP, it's Python, or it's C programming, or it's Java, we have the garbage collection process, which just states that if there's a variable that is not being used for a long time, then it's that variable is collected and destroyed. Okay, and the memory that was allocated to that variable is freed, and that's all that garbage collection is. And it's just talking about the advantages and disadvantage of that. It is making the programmers more effective, and it ensures the program integrity. And then the disadvantages is that it adds the overhead, a cost to the system. Overhead means cost. It adds cost to the system, which adversely affects the program performance, which means the program is supposed to do XYZ, but it's also going ahead and doing garbage collection. So it's doing a little extra. And of course, programmer will not have control over the scheduling time and all of that, because that's handled by the system itself. Okay, now we talk about the final keyword. Yes, Kritika?
I thought I was supposed to read this. Um,
Yeah, yeah,
okay.
you go ahead.
Yes, the final keyword is a non access modifier used for classes, attributes, and methods, which makes them non changeable, impossible to inherit or override.
Right. So there are two things. There's final keyword and then there's final method also. Okay. So the difference between the two is that the final method, if you define a final method inside of a class, the whatever you do inside of it will always be executed. So that method is always going to be executed. While in final keyword, if you declare the value of final, a variable as final, the value of that will not be changed. So in simple word, think of final as constant, right? So if you want to declare a constant, let's say pi value, you know that value of pi in mathematics is not going to change, it'll always be the same. So if you are defining some sort of constants where you know that its value is not going to change, you just put final keyword before that variable, and that's all that final is. Okay. And now in this program, all we are doing is we're trying to change the value of this x, and as you can see, it's not doing that. It's saying that you cannot assign a value to a final variable, and that's all that's happening here. Okay, go on. I think I've already explained this value of pi, so it's no need to read this. Okay, this is finalize method. Yeah, I think this is one I was talking about. It's called finalize, not final. Yeah. Carry on, Pritika.
Finalize method in Java is an object class method that is used to perform cleanup activity before destroying any object. It is called by garbage collector before destroying the object from memory. Finalize method is called by default for every object before its deletion. This method helps garbage collector to close all the resources used by the object and helps JVM in memory optimization.
Okay. So Maya, can you think of any situation where we would need to use a finalize method? Any example?
I don't know.
Okay. In database, right? When we're handling databases, we open a database connection and
Yeah.
then we have to close the database connection also once everything is done. So I'm not 100% sure, but probably that could be a thing like when you want to close the database connection that you can do in the finalize. Okay, so I think this is self-explanatory that I've already explained that this method will be called always. This will always get called. Other methods you have to call it like when you instantiate an object, you have to actually call them if you want to use them. But this method will always get called at the end. Okay, features of Java. Okay, so Maya.
Features of Java. It's based on object oriented programming concepts.
Mhm.
Everything in Java is an object. Objects promote understanding of the real world problems in a natural way. They provide practical basics for implementations of the design of the system. It's simple and secure. Java is easy to understand and write, having user friendly syntax. We can develop a virus-free system using Java programming language because it has no explicit name pointer. It runs inside a virtual machine sandbox.
I can think of this question to be asked during our um Viva, possibly because I remember we were asked about features of uh, Python and all that in Viva. So, so maybe at that point this question might be asked, and the answer to this question is quite similar to other programming language. Like other programming language is also simple and secure. So even if you don't remember anything, you can think of whatever you prepared for the other languages. It's pretty similar. The main thing you need to remember is that everything in object is Java because it's object oriented programming language. Okay, and easy to understand, right? User friendly syntaxes, although I find that Python has better syntaxes than Java, but yeah, fine if they're saying so. And yeah, go on.
It's portable. Java facilitates you to carry the Java bytecode to any platform. With the help of bytecode, you can run the Java program on any computer virtually. Java provides three types of portability: source code portability, CPU architecture portability, and OS GUI.
uh, on what thing this Java bytecode runs?
On the JVM,
Correct.
it's robust.
Mhm.
Java provides an automatic garbage collector that runs on the virtual machine and destroys the objects which are not being used in the program anymore.
Okay. So this code that you write, of course, you can develop apps using Java, mobile apps, and if the code is portable, so that's what he's talking about. It's robust. Okay.
It's multi-threaded. Java runtime systems come with an elegant solution for multi-process synchronization that enables you to construct smoothly running interactive systems. Architecture neutral. Java Virtual Machine was designed to write once, run anywhere, anytime. Interpreted and high performance. Java bytecode can be translated into native machine code using just-in-time compiler, which is faster than the standard JVM.
Okay, we'll talk about this just-in-time compiler, JVM, all of those in detail in a little while.
It also facilitates running one time and caching the results for future.
Okay. Okay, this is the architectural neutral. You have Java code which you write. When you write Java code, you create class files with the .java extension that is run by the Java compiler. Compiler converts into bytecode, uh, and that bytecode is then run by the Java virtual machine. And what this is talking about is that it can run in different platforms. It's platform agnostic, so you can same JVM can run it on Windows or Linux or Mac, and that's the meaning of architectural neutral. Okay, okay, go on.
It's distributed. After compiling the Java program on one machine, it can be transferred on another machine to execute because of its bytecode facility. It supports remote method invocation, which enables a program to invoke methods across a network. It's dynamic. Java programs carry substantial amounts of runtime type information that is used to verify and resolve accesses to objects at runtime. This enables tooling code safely and expediently and
Experiently,
dynamically.
fast. Yep.
Using class loader, you can also load a new already compiled class at runtime in a standard language supported way.
Okay, now we talk about the Java development environment too. So we studied about the theory. Of course, I think in exam most of the questions will be theoretical. There could be one or two where you have to write a program, but I think majority of the time it's going to be just theoretical. But if you want to develop it, I'm just going to talk about what these development tool are, and we're not going to revise all of this. Probably these questions might be asked in Viva as to what tools we'll use, how will you install it and stuff. So we'll just take a look at this once. So you can write, compile, and edit Java programs in two ways. First is command line environment. Like remember when we were doing Python, we were able to run it on the command line interface CLI, that terminal that we had seen, and we could also do it through the core editor. The same way for Java also, you can run it via command line tool, or you can use an IDE. You can use IntelliJ, uh, which I will show you in a moment. You can also use VS Code for this as well, and install the relevant extensions. So NetBeans and Eclipse are two free and popular IDEs for developing Java program, and there's IntelliJ also, which I'll be using, which is also free. Components of Java development environment. The key components of the Java development environment are JDK, which is Java Development Kit, JRE, Java Runtime Environment, JVM, Java Virtual Machine, and GIT, which is just-in-time compiler. The components JDK and JRE interact with each other to create a sustainable runtime environment that enables seamless execution of the Java-based applications in virtually any operating system. So let's take a look at these components which we just spoke about. So you have from starting from here, you have JDK, which is development tool, and then you have JRE, which is Java class library. You have JVM, and you have JIT, just-in-time compiler. So every module of Java comes under JDK. So this is the whole thing. So everything that you see inside of this is basically inside of JDK. JRE is a library, Java class library. JVM is an instance of JRE. While executing the Java program, it is a runtime interpreter, so Java virtual machine. JIT is a part of JVM. It's part of Java virtual machine that is used to speed up the execution time. So this helps. This is inside of JVM, and it helps to speed up the process of execution. It does that by compiling the parts of the bytecode that have similar functionalities simultaneously. Okay, so now we have looked at like an overview of these components of development environment. Now we'll go into detail. So first is Java Development Kit. So Java Development Kit is that wraps everything inside of it. It's a software development environment which is used to develop Java applications. It contains JRE along with the development tools. JDK contains a private virtual machine. So look at this example. This contains a private uh, Java virtual machine and a few other resources like interpreter, loader, Java compiler, archivers, and Java doc for the documentation generator to complete the development of Java applications. Now we talk about the Java runtime environment. Software layer that runs on top of the computer's operating system provides the class libraries and other required resources to run specific Java program. GRE runtime architecture generally uses class loaders, which dynamically loads all the necessary classes to run the program. It also automates the loading of the classes as per requirement so it can effectively utilize the memory. Bytecode verifier, it uses bytecode verifier which checks the format and accuracy of Java code before it passes that to the interpreter. It also uses interpreter which helps run the Java program natively on underlying machine. Now we talk about just-in-time compiler and JVM. They go hand in hand. That's why we're discussing it together because JVM contains JIT. So JIT, an integral part of Java virtual machine and garbage collector. Uh, JIT can compile Java code into machine code, which can significantly improve the performance of the Java application. It usually compiles the code as per the requirement to JVM. Once the method execution crosses the certain limit, then it will be converted into machine code. Okay, programs written in Java compiled into machine language, but it is machine language for a computer that does not really exist. This is what we call virtual computer, is known as Java virtual machine. The machine language for JVM is also known as Java bytecode. This code enables us to run the program on any computer. So all this is talking about is that um, machine language doesn't really exist. That is why we use a virtual computer, which is called Java virtual machine. Okay, and it converts it into bytecode, and that bytecode can be run into any computer. Okay, now flow of the program execution, how it's executed. To run a simple program in Java programming, we have to use the Java compiler to convert the source code into Java class code. And after that, JVM is responsible for running that program. So let's take a look at from here. So let's say we have a class file. We've written a code called welcome.java. The name of the class is welcome and it has the Java extension. This is your source file. This is where we've written the code. What compiler is going to do is compiler is going to compile it and then is going to generate welcome.class, which is a source code file. Okay, that is going to be executed by, of course, it'll require the library code which will be given to it using JRE, if I remember it correctly. JRE, yeah, this one. It has the class libraries. Yeah, yeah. So that is going to provide all the necessary classes for it to work, and this code is going to be executed by JVM, and that JVM is going to output that program. So that's the flow, basically, flow of execution of how the Java program run in a nutshell. Okay. Data types in Java. This is, I think, this is an important question. It's high chances might come in the exam also because it's part of the assignment. And this is the first question in the assignment. Okay, so what are different data types in Java? So Kritika, can you read this?
Yes. Data types in Java, primitive data types. The primitive data types include Boolean, char, byte, short, int, long, float, and double.
Yeah, if you remember in the C programming also we had the same thing. So
Yes.
here also we have these data types.
Non-primitive data types. The non-primitive data types include classes, interfaces, and arrays.
Okay, so
Um,
this is your primitive data type. You have booleans. The default value is false. Size is 1 bit. Char default value is this. Side is 2 byte. Byte default value is 0. 1 byte. Short is 0. 2 byte. So maybe you can remember this and then you can write this in exam. Yeah, go on.
Non-primitive data types are classes. A class is a template or blueprint from which objects are created. It has properties and methods.
Yeah, so we already
Interfaces,
learned about the classes, right? So we already know what classes are, so we can describe that. Yeah, go on the interface.
interfaces. An interface in Java is a blueprint of a class. It has static constants and abstract methods. It is used to achieve abstraction. By interface, we can support the functionality of multiple inheritance. It can be used to achieve loose coupling.
Hmm. Okay. So first thing is that objects are basic. Okay, so class is the blueprint is what we discussed earlier, right? Similarly, interface is the blueprint of a class, and again it has your methods and constants and all of those things. And the main use of this is to achieve abstraction, which means hiding the details and just showing the essentials. If you remember when we were discussing inheritance, we discussed about single level inheritance, or we discussed about multi level inheritance and hierarchical inheritance. And we said that Java does not support multiple inheritance, right? So, in scenarios where we do need multiple inheritance, what do we do? Because Java doesn't support it. So, that is where interface helps us. And this is the third point, which says by interface, we can support the functionality of multiple inheritance, which is by default not supported by Java. Okay, so we'll take a look at it later, how to actually do that. Okay, yes, let me just change the animation of this. Okay, this was done. Let's continue with this. Okay, yep, go on, Kritika.
Yes, non-primitive data types, arrays. Array is an object which contains elements of a similar data type. Additionally, the elements of an array are stored in a contiguous memory location.
Yeah, so if you remember, this is the exact same definition we had learned in C programming also, that array is basically containing similar type of data, right? So again, in Java, everything is an object. So array is also an object which contains similar type of data. And we also learned in C programming that the elements are stored in a contiguous memory location, which means one after the other. So there's no space. Let's say there were different boxes, 0, 1, 2, 3. So it's in in like a same sequence. There's no break in between. That's the meaning of contiguous. Okay, let's take an example of this particular class. So there's a class called test array, and this is your main function which will get executed always. And how to declare an array? So of course, anytime you declare a variable or a class, anything in Java, you have to declare its data type. So the variable name, the array variable name is a, data type is int, and then you put the square bracket and you put equals, and then new and int, and then what's the size of this array, how many elements are going to be there. So here we can put 5. Okay, so this is just declaration. Okay, and if you want to initialize it, like basically set its value, you can do that either here or you can do that like this. Okay, If you were to do it here, you will put those value in the bracket, like 10, 20, 70, 50. But you can very well first just declare it and then initialize it later, like so. So first element you have set the value, second element, and so on and so forth. If you want to loop through it, again, you can use the for loop. This is very, very similar to what we did in C programming. So for int I equals 0, I less than a into length I plus plus. And to print something, you'll use system dot out dot print. System is a class in Java, and the method is out dot println. Uh, there's another function called print. The difference between println and print is that println will create a new line after printing the value, while print will just print it. There will not be any new value. Okay, and then just put this value, and it's going to go ahead and print that out. Okay, carry on, Kritika.
We can store only the fixed size of elements in the array. It doesn't grow its size at runtime.
Okay, so we have defined size 5, and it's going to be fixed. We can't really increase it. Okay.
Single dimensional array, a list of variables of similar or same data type.
Yeah.
We can access values using index.
Correct. So this is what I was talking about. In the previous example, we saw that we just declared it, but we did not set its value. We set its value later on during the program. So if you were to do it like that, this is how you do it. But if you want to declare and initialize at the same time, see this example, the difference in this and this. So in the previous one, you use new int and you just declared it, but you didn't set any value. But here you're directly setting the value. Okay, so that's how you do that. Okay, so single dimension array, again, it's the same thing. Let's go on to next. Yep.
Multi-dimensional array is an array of arrays that use more than one index to access the array elements.
Okay. So multi-dimension means there are more than one indexes. So syntax is data type, first dimension, second dimension, up to n dimension. Okay, and then array name equals new, and then data type, size 1, size 2, size 3. Okay, so data type you already know about it. Dimension is the dimension of the array created. For example, one dimension, two dimension, etc. Array name is the name of the array, so name of the variable. Size 1, size 2 is sizes of the dimensions respectively. Let's take an example of a two-dimension array. So in one dimension array, you are only using a single bracket, but here since it's two-dimensional, you use two brackets, then the variable name, then new int, size of the first dimension, and size of the second dimension. Similarly, for three dimension, this is how you create it. You put three brackets and you put specify the size of each one of them, which means this will take 10 items and this will take 20 items. What's the difference between static and dynamic array? So yeah, go on.
Static array. Static arrays are declared before runtime and are assigned values while writing the code. The static arrays are allocated memory at compile time. A
Hmm.
dynamic array. The dynamic array is declared while writing the code, and code and memory is allocated at the runtime.
Okay.
Um, Static array int array 3 declared.
Hmm.
I don't know how to read this. Int array brackets
Square bracket. Square
square
bracket
brackets
equals curly braces.
is equal to curly braces 1 to 1 comma 3 comma 4 close bracket close curly brackets semicolon static array design assign val
Hmm.
um, int star array dynamic array int star array is equal to new int square brackets 3 semicolon dynamic integer array.
Okay, so in static array, you can see that it's just declared here and the value is assigned over here. And in dynamic array, you are declaring it here, but the values again will be, so what is talking about, the memory is allocated at runtime. Dynamic array is declared while writing the code, and memory is allocated at runtime. Static array declared before the runtime and assign the values while writing the code. Okay. Allocated compile time. So the difference between the two is that the memory is allocated at compile time for static arrays, and this is done at the runtime. Carry on.
The size of static array is fixed. The dynamic array is a variable size. It grows automatically when we try to insert an element if there is no more space left for the new element.
Yeah. Okay.
Stat- Static array, it is located in stack memory space. Dynamic array, the memory is located from the heap.
Hmm. Okay. So when we know that the size is going to be fixed, we use static array. When we know that size can change, we'll put a star here, and then later on we can put more space inside of that.
Are there pointers in Java?
I haven't read about. I mean, I haven't in the entire course. I haven't seen pointers.
I thought the star was for pointer, but it means something else.
I'm not sure. You can check that. Dynamic Java. Mm. I'll leave the question to you. So Maya, you can you tell me tomorrow on the call?
Yes.
Okay. Okay. Program to bring the sum of all the array elements. I'll just take you through this. There's a class called sum of array. There's a main function. We initialize the array int square brackets array new int square brackets, and this we are putting the value of this array 1 2 3 4 5. Sum equals 0, and then just loop through array. Initially sum is 0, so in the first iteration this value will be 0 plus 1. Second iteration, the value becomes 1, so 1 plus 2 with 3. The third iteration, this becomes 3 plus 3, so this keeps on adding. Finally, once this loop gets finished, the sum, we would have received the value of the sum, and we're just printing it out here. Okay, we talk about unique code. I don't think it's that important, but we'll read it anyways because we never know. They can just give question from anywhere. So Unicode is 16-bit character encoding standard, and it's capable of to represent almost every character well-known languages of the world. So of course, machine doesn't understand A, B, C, D. So for that, you have that Unicode. Before Unicode, there were multiple standards to represent character encoding. Uh, ASCI, American Standard Code of something like that. I don't remember the exact full form of this. ISO, KOI, etc. Some character was using single byte, some two to support multinational application codes, and even same code may represent a different character in one language and may represent other characters in other language. So to overcome above shortcomings, the Unicode system was developed. So there was a lot of like different things supported at different places. There was no uniformity. So I think to uniform to make it standard to standardize thing, they developed the Unicode so that everybody follows the same thing. Where each character is represented by 2 bytes. As Java was developed for multilingual languages, it adopted the Unicode system. So lowest value is represented by uh, backslash u 4 times 0, and the highest value is represented by backslash u 4 times f. This is a Unicode value. Okay, now we talk about variables. Variable is the name of the reserved area allocated in memory whose value can be changed. Question: if you want to define a constant, what is the keyword will you use? Sumaya?
Final.
Yeah. Okay, so first is local variable. It is declared inside the body of the method. You can use this variable only within that method, and other methods in the class aren't even aware that the variable exists. A local variable cannot be defined with static keyword. Okay, so this basically talks about that local variable is the variable inside a particular method of a class. So let's take an example. Let's say there's a method called method, function called method, and we declare int n equals 0. So this is local to this. It's not going to be available outside this function, even in the same class. It's only available here. If we want it to be available inside the class anywhere else, we have to declare it on top, outside this function. So local variable means it's going to be within that method, accessible only within that method. Then we have instance variable. A variable declares inside the class but outside the body of the method. So, like I explained earlier, that if you declare a variable inside of a method, it's not available anywhere inside the class apart from this method. But if you want something to be available everywhere in the class, then you have to use the instance variable, which is declared here. So that's what it's talking about. And that type of variable is called instance variable. Variable declared inside the class but outside the body of the method. It is not declared static. It is called an instance variable because its value is instance specific and is not shared among instances. Example, so you can see that we are defining it inside of a main function, not inside of standard functions. Why is it called? One second. It's saying outside of the method. And why defining inside of main? Mm, yeah, I think that example probably is not correct. So this is how you declare it on top, which is outside the method. And then if you give it a access modifier, that becomes that type of instance. So this is public instance available publicly, this is private, and so on and so forth. Okay, I'm going to remove this and probably, okay. Okay, then you have static variable. A variable declared as static is called static variable. And I think we read about it that if you declare a variable as static, then it is available irrespective of whether you create an object out of that class or not. So it is accessible without instantiation. It cannot be local. You can create a single copy of the static variable and share it among all instances of the class. Uh, Share it among all instances of the class means, let's say you create three different objects, that particular variable will be available in all of those three objects. Memory allocation for static variable happens only once when the class is loaded in the memory. For example, this static int m equals 100. This is static variable because there's a keyword called static. Okay, I think that's it. That should be it for today. It's already 7. We'll talk about operators tomorrow. Okay. Cool then. Thanks, guys. I'll actually tomorrow and day after I will not be taking the class because I'm busy. So I'll directly take the class from Wednesday onwards. Okay. But all the best for your studies.
Okay, thank you.
Welcome. Bye bye.